All right, now this is our final video for part 5, section 1 of our pre-calculus series. And in this video, we're going to be talking about how to use reference numbers that we talked about in the last video to find the terminal points for just any real value t. So first, I'm going to start off with an example, and this example will hopefully kind of lead us into what we're going to be doing here. So let's say I have a t. Say I have t equals 17 pi over 6. And I want to find the terminal point P. Right? P equals what? What is my terminal point P? And what I claimed before is that we're going to be able to do this using just reference numbers and this chart, which I've rewritten up here, of these common values. All right, so let's look into why we can do this and why I can make that claim. So if I have this t equals 17 pi over 6, first let's break this down a little bit, right? 17 pi over 6, that's the same as 12 pi over 6 plus 5 pi over 6, isn't it? Ugly 5. And remember, 12 pi over 6, we can reduce that down to 2 pi, and then we have plus 5 pi over 6. And as we've discussed in the past few videos, any increment of 2 pi we can kind of ignore. Again, not because 17 pi over 6 and 5 pi over 6 are the same number, but because 2 pi over 6 represents one full rotation. So the terminal points determined by 17 pi over 6 and 5 pi over 6 are going to be the same. All right, so let's look at 5 pi over 6. It's the same as 17 pi over 6 for what we need here. 6 pi over 6 is pi, so that's a half rotation around the circle. So that means that 5 pi over 6 is going to be just shy of that. It's going to be about right here. Right, so this is for a t is 5 pi over 6. Or, you know, keep in mind, we're actually looking at 17 pi over 6. Okay, so now I want to look at my reference number. We want to figure out why in a second here. But my reference number here is going to be this distance here. And remember, 17 pi over 6 was one of our examples before, and we found that our reference number t bar was equal to pi over 6, wasn't it? We know that 6 pi over 6 takes me all the way to the x-axis. So if I go 5 pi over 6, that means I'm just 1 pi over 6 of the way to the x-axis. Now, why does this reference number help us? Well, let's take a little look here. If I look at this kind of geometrically, notice that if I take a line, this is my point P right here, isn't it? Oops. This is my point P right here. Now, if I look at a line straight across, parallel to the x-axis, right, I'm going to have a point over here. We'll call this Q. And this point Q is going to be determined by a t of pi over 6, isn't it? So that's the same as my t bar of pi over 6. Now, why is this helpful? Well, I know my line's a little slanted here, but if this line's parallel to the x-axis, that means that whatever the y value is of this point determined by pi over 6 is going to be the same as the y value over here, isn't it? So I know right away that because Q from my chart here has a y value of 1/2, P must also have a y value of 1/2. Well, similarly to an example that we saw before, I can plug this into my equation for the unit circle, and I'm going to get x squared plus y squared, now y is my 1/2, equals 1, right? I know this is on my unit circle, so I can say equals 1. So that means x squared is equal to 1 minus 1/2 squared. 1/2 squared is 1/4. So then x squared is equal to 3/4. And then we end with x is equal to, now don't forget, plus or minus square root of 3 over 4. Now there's two solutions here. If x is, oh, sorry, I made a mistake here, didn't I? Plus or minus square root of 3 over 2. Remember, we got to take the square root of that denominator as well. So I have two solutions here. The positive solution, x is equal to positive root 3 over 2, well, that's this point q here, isn't it? So I have this point positive square root of 3 over 2, 1/2. That's this point q determined by my reference number. So then p is going to be the other solution. It's going to be negative square root of 3 over 2, isn't it? Okay. So what I've done here is a little bit longer than what we'll be doing in a typical scenario. But let me remind you of something. Notice here that I have here, this is positive square root of 3 over 2, positive 1/2. Over here, my p is negative square root of 3 over 2, positive 1/2. Now I would have some other value directly below p that would be negative square root of 3 over 2, negative 1/2. And it would also have a reference number, t bar, of pi over 6, wouldn't it? And I'm going to have another value directly below q that's going to be positive square root of 3 over 2, negative 1/2, right? I have four different combinations: positive, positive, negative, positive, negative, negative, and positive, negative. And this one is also going to have a reference number of pi over 6. Okay, so what does this mean? This means that we can generalize this result given by this example, and we can have an algorithm that's going to help us quickly and easily find these terminal points P just by using the reference numbers. Now I've typed this algorithm out, make it a little bit easier for you to read. So it's going to be this three-step algorithm. Okay, now our first step is going to be to find t bar. If we're given a t, we want to find t bar first. Second step, we want to find the terminal point q determined by t bar. And I've said q with an x value of a and a y value of b, whatever that is. And we'll be finding that based on our chart, right? Our reference number is always going to be in this chart here, because it'll always be less than pi over 2. And then our third step and final step is the terminal point determined by t, my original value t now, not my t bar, is going to be p plus or minus a plus or minus b, where the plus and minus are determined by the quadrant of p. Just like we were looking at here, there were four solutions for any reference number, t bar. And just another quick reminder, let's see if I still have this. Oh, here we go. A quick reminder of our quadrants, right? In quadrant 1, we're looking at positive, positive. Quadrant 2, my x is negative, my y is positive. Quadrant 3, both x and y are negative. And quadrant 4, I have a positive x, a negative y. So I'm going to use t bar to find q, look up that q on this table, and then depending on where p is, I'm just going to change the sign so that the signs match these signs on my quadrants. And that's it. So let's do some quick examples of this. We do a couple of examples, and that'll finish up this section 5.1. And I want to leave all of this up here so we can refer to it. So I'm just going to make a little box over here, and we'll do the problems over here. We should be able to fit it in this bottom right corner. Okay. So let's say I have a t, let's say I have a t of 3 pi over 4. Okay, so remember 4 pi over 4, 4 pi over 4, that's going to be pi. So 3 pi over 4 is going to be 3/4 of this top circle. Right, so I'm starting here at my initial point. I'm going 3/4 of the way around this top circle. And that's going to give me a t of 3 pi over 4 right here. Now from here, I want to find my t bar. Now t bar in the second quadrant, that means I'm going to be finishing up here, right? T bar, remember, is going to be equal to pi minus 3 pi over 4 when we're in quadrant 2, right? Or pi minus t. So my t bar, we'll document that over here, is going to be equal to just pi over 4. Pi over 4 is the additional distance I'm going to need to travel after t in order to get back to the x-axis over here. Okay, so that's step 1, find t bar. Step 2, I want to find the terminal point q determined by t bar. So I'm going to use my table just above. Q, based on t bar being pi over 4, means that q, just looking at this table here, is going to be the square root of 2 over 2, square root of 2 over 2. All right, now we just have one more step. Remember, this is my p right here, determined by t. It's in quadrant 2. That means my x value is going to be negative, and my y value is going to be positive. So my p is just going to be whatever q is, but I change those signs based on this quadrant 2. So I have p, my x value is negative, so that's negative root 2 over 2. And my y value is positive, so that's positive root 2 over 2. All right, so that's my solution. My terminal point, determined by t equals 3 pi over 4, is this point, negative root 2 over 2, positive root 2 over 2. And the more of these that we do, the more natural it's going to come. It'll become very simple. You won't need to necessarily go through this entire algorithm every time once you become used to these values. So let me clean up here, and we'll do one more example before we finish up this section. Okay, let's say I have now a t equals 7 pi over 6. That should be a good one. All right, now 6 pi over 6 is the same as pi. So 7 pi over 6 means that I'm going 1/2 rotation around my circle, and then I'm going an additional pi over 6, isn't it? So this is t equals 7 pi over 6. This is my point P right here. So as I just said, I went all the way pi, and then I went an additional pi over 6. So that means my t bar, this distance right here, is going to be pi over 6, isn't it? So let's document that over here on the right. My t bar is equal to pi over 6. Now, step 2, I want to find the terminal point Q determined by t bar. So looking at my chart above, Q from pi over 6, that's going to be root 3 over 2, 1/2. And our final step, step 3, the terminal point P, it's going to be the same as Q, but I changed the plus and minus signs based on the quadrant of P. Now P is in quadrant 3, that means I have a negative x value and a negative y value. So my P is going to be negative square root of 3 over 2, negative 1/2. All right, and this finishes up section 5.1. If you're in my class, feel free to email me if you have any questions. And if you're just watching these videos, I hope that they were helpful for you.